Okay, ladies and gentlemen, we're going to be talking about metal reactions today, and so let's get right to it with these metal reactions. The first one we'll start with is the alkali metals, and these are going to be, of course, group 1A. These metals that react with water to form a metal hydroxide, and a metal hydroxide, there's the formula of it, and they're also going to form some hydrogen gas. So here's our general format. Generally, we get two alkali metal reacting with 2 moles of water to form 2 moles of metal hydroxide plus a mole of hydrogen gas. So here's an example. Maybe we could take some potassium metal and react potassium metal with water. And so what's going to happen is this potassium will come in and replace the hydrogen, and so it's going to leave us with hydrogen gas being produced. And we're also going to form, in this case, because we have potassium, we're going to form that KOH, that potassium hydroxide, in an aqueous form because it's in water. And now we're just balancing it. Throw a 2 in front of everybody here, and a 2 in front of the potassium, and that gives us our metal hydroxide there. And so that was a review. Let's move on here. Now we're going to talk about alkali metals when they react with oxygen. And now alkali metals when reacting with oxygen are going to do something a little bit tricky here because it does 3 different things as we go down the alkali metal group. So if we have solid lithium, as we have here, reacting with oxygen gas, it's just basically a synthesis reaction or combination reaction where we're going to have lithium oxide formed. Just as a reminder, remember that lithium is a 1+ charge and oxygen is a 2- charge, and that's where we get the formula here of Li2O. Not a big deal at all. And typically when we have solid reacting with gas, we're going to form a solid. The next one is as we go down the alkali metal groups, we get to sodium, and when it reacts with oxygen gas, it's going to do something different. So sodium plus oxygen gas is not just going to form sodium oxide, Na2O, but it actually does form Na2O2, which is the formation of sodium peroxide. Now the peroxide ion is basically a diatomic oxygen with a 2- charge on it. That's the peroxide ion. So that's what we have forming here. So lithium is just a regular combination. Sodium forms a peroxide. Now, on the next one, if we get down to potassium and below potassium, it's going to do something even stranger, and it's going to form what's called a superoxide. So potassium plus oxygen yields a superoxide, KO2. The superoxide formula is essentially a diatomic oxygen, but it's only going to form a 1- charge in this case, and that's why we get this formula, because remember, potassium always forms a 1+. So this is kind of just a strange occurrence in the alkali metal groups, only when they react with oxygen. Okay, now we're going to get into the hydrogen group. Now hydrogen is, we know, a very unique element. It's most often a diatomic colorless gas. And so we know we get H2 whenever we're talking about hydrogen, one of those 7 diatomics. And what makes it so unique is, of course, hydrogen is, it behaves like an alkali metal with that 1+, but it can also do some other things that are interesting. Like I said, it can behave as an alkali metal forming a 1+ charge right here, but it can also form what's called a hydride ion, which is the hydrogen 1- charge, where it gains an electron rather than losing an electron, really depending on who it's around. So here's a good example. When we have the alkali metal sodium reacting with a hydrogen gas here, we are going to form what's called sodium hydride. Here, sodium is acting as a non-metal by gaining an electron, sodium having that 1+ charge, hydride having that 1- charge, crisscross those charges. We can also have hydrogen reacting with oxygen, and this is the fun way to make water, is you take hydrogen gas and oxygen gas and you give them a little heat in the form of a flame, and you're going to make water. And so that's an interesting one to keep in mind, and we'll take a look at that later on in the lab. We also need to remember, and this will become very apparent once we get into our acids and bases, that hydrogen is a proton, because essentially on the periodic table, hydrogen has an atomic number of 1, and it has an average atomic mass of 1, and so we would say that hydrogen is essentially 1 proton, and it has 1 electron in the neutral form. But once it loses that electron, it's only a proton. If we subtract these two, hydrogen does not have any neutrons whatsoever, and so hydrogen is just a proton. Aqueous chemistry of hydrogen is dominated by the hydrogen ion, and like I said, we'll get into that very deeply once we get into bases and acids and stuff like that, and start looking at pH. Now, getting into the alkaline earth metals group, the group 2A, these guys are a little bit harder, more dense than the alkali metals, and their chemistry is dominated by the loss of 2 electrons, and we know that. We know that when alkaline earth metals form a charge, they form a 2+, beryllium, magnesium, calcium, strontium, barium, and they're going to lose 2 electrons. Some of the interesting things that occurs with alkali metals. First off, if you have beryllium, very unreactive, does not react with water at all. So we're not going to get a reaction. If we were to take magnesium and drop it in water, it's not going to react. But if we were to heat that water up to once it gets into 100 degrees and we have steam, we can definitely get a reaction out of it. Now, once we get up there in the calcium, strontium, and the barium range, these guys will all readily react with water, just liquid water. It doesn't have to be steam. And what they're going to do is they're going to form an alkali metal hydroxide. Those are going to be our strong bases. And remember that that when we looked at strong bases, those bases that ionize 100% of the time, it was calcium, it was strontium, and it was barium. The other thing to remember here is they're also going to form a hydrogen gas when they do this. Now that's an interesting aside. And here's just throwing out a couple other kind of cool alkaline earth metal reactions. This is just going to be a combination reaction where you have magnesium reacting with chlorine gas, and we're just going to form magnesium chloride over here again, remembering 2+ charge formed by an ionic compound, and then a 2- charge formed by a non-ionic compound. Just right there. Let me zoom back out there real quick. There we go. Here's a reaction that we just take magnesium and we're reacting with oxygen. Now, of course, we have to give this a lot of heat to get it going, and it's going to form magnesium oxide, which is a metal oxide. So typically, remember if we talked about metal oxides, if we take this metal oxide and we react it with water, anytime metal oxides react with water, these guys form bases. So you're going to make a metal hydroxide there. Okay, so moving on here. And the last thing that we're going to talk about today is essentially that we have a summary of some alkaline earth metal properties that are important. Notice the electron configuration, as we've talked about, is basically the same. We have it increasing in those 6s electron, or the s2 electrons, are being further and further away from the nucleus up there in strontium and barium. Our melting point is decreasing as we go down the period. That's the temperature at which these guys melt. Our density is actually increasing as we go down, which would kind of make sense because you have increasing mass. Atomic radius, as we know, is increasing because atomic radius increases with principal quantum number n, and Earth's ionization energy is going to decrease as we go down, and we know the reason behind that now is that you have those outside electrons, those 6s2 and 5s2s, further away from the nucleus. There's less chance of having that positive pull by the protons, and you also have some shielding going on there by the inner core electrons. And so that's essentially what, that's tonight's lecture, and there's going to be also some few problems.